Hello, this video is about speed, acceleration, and distance. So we learned about speed has a symbol v. That's going to be equal to distance over time. So that's distance over time. So in SI unit, that will be meter per second. And for US unit, that will be foot per second. All right, that's for the speed or velocity. The difference between velocity and speed is velocity has a direction. For example, it's going to north or going to 45 degrees from positive x-axis. However, speed is just a number. It's just a magnitude. It's 2 meters per second. Didn't tell us what direction it's going. So then acceleration. Acceleration has a symbol A, and it's defined as change in velocity over time. Okay, so let's look at a quick example on this. Initially, this car is going V1, that's initial speed, as let's say 2 meters per second. And then it's accelerating and gets you final speed V2 as 10 meters per second. And this process take about, let's see, it take about 4 seconds of time total. So then getting back to this definition for acceleration will be V2 minus V1. That's the change in velocity. And it take divided by the time for this process to happen. That's 4 seconds, right? So we have 10 meters per second minus 2. Then divided by 4 seconds. So you do the math, we'll get 2, and let's figure out the unit. The unit is right here, right? So you have a meter per second, then divide by second, so it's meter second square. That helps us to figure out what's the acceleration unit. For SI, we'll have meter per second square. And for US unit, we will have foot per second square. Right, that's acceleration. Now let's look into distance. Well, distance is easy, right? Because you can actually going back to this equation here to look at the distance. So distance d is going to be equal to velocity times time. Okay. Now let's look at a quick example. So imagine you are starting to drive your car, and initial speed, we're going to draw this. X-axis will be time, and we use seconds. And this is going to be our speed or velocity. And here we're going to use, let's see, how many meter per second. Okay, so initially you're driving this car and it start at rest in the garage, and when you come out you start to accelerate, and once you get into the highway, get on the highway, and so that's going to be your highest speed, and then it's hypothetically assume that's going to be well, what, like 20 meters per second. Okay, and then you just go on the highway. It's smooth sailing, you know, for a long time. Oh, by the way, from 0 initial speed to this 20 meters per second, that takes you about, let's see, 5 minutes. So 5 minutes, that's going to give us 300 seconds, right? Then you smooth sailing and for a while, and that's going to take you 1 hour, okay? 1 hour, that's how many seconds? 1 hour is 60 minutes, and then each minute is 60 seconds, so that's 3,600 seconds right in the stage 2, okay? We call this stage 2. This will be our stage 1 acceleration. And then you get into the exit and you are reducing your speed, and then you go to the destination you wanted. You stop there. And this deceleration process, let's say you take about only 3 minutes. That's going to be 180 seconds. Okay. All right. So from here to here is 180, and from here to here, that's 3,600 seconds, and from here to here is 300 seconds. Okay, and we call this stage 3. So recap, stage 1 is where you accelerate from 0 speed to 20 meter per second, and you smooth sailing for about 3,600 seconds at this constant speed, 20 meter per second. Then you decelerate for 180 seconds from 20 meter per second to 0. Okay, so there are a few things we can actually figure out from this graph. The first thing we want to look into is at stage 1, what's going to be the acceleration? Okay, so we learned acceleration is velocity change over time. And what's going to be the final speed? The final speed is going to be this point. That's 20 meters per second. Initial speed is right here, 0. And how long does that take? That takes about 300 seconds. So then we can quickly calculate our acceleration. So 20 over 300, that's gonna give us 0.15. Nope, wrong. 20 over 300, that's gonna give us 0.06 repeating. That's gonna meter per second square. Okay. So you got this positive value for acceleration because the final speed is greater than the initial speed. So you get positive acceleration. Then let's go back to stage 1 again. You figure out the acceleration. Then we need to figure out how long, what's the distance you travel during this acceleration. Okay. And we know the distance is going to be formula is equal to velocity times time, or speed times time. Well, the speed here is not a constant value. It changes from 0 to 20 millisecond per second, meter per second. So we need to find average speed. What is this average speed? Average speed is going to be initial plus final, right? Divided by 2. So that's going to be our average speed. And initial speed is 0 and final speed is 20. And then divided by 2, that will give us, for this acceleration, average speed is about 10 meters per second. Then, so we can go ahead to write down here. So that's going to be add a subscript average. Going back to this formula for distance, d1 is going to be average speed. It's 10. You calculate it here. Then how long does this take? It's 300 seconds. Then we got our 3,000 meter. So that's the distance they traveled. And let's go ahead and break up those two answers. acceleration and distance. So here I would like to really pay attention to this graph, going back to this graph. Because in calculus, you learned about that if this is speed, this is time. We learned about derivative of speed over time. That's gonna give us acceleration, right? And what's really derivative? Derivative means slope. So yeah, in other words, we can just look at this graph to figure out the acceleration, because the acceleration here for this stage 1 will be just the slope of this linear line. That's going to be our acceleration. And how do we figure out the slope? So here is use graph. You can figure out the slope. 1 for stage 1 is going to be equal to rise over run, right? In other words, delta y over delta x. And the y-axis here is speed. So it's delta v over delta t. T is x-axis. So delta v from this point to this point, the rise is, the vertical distance is 20 meters per second. And what's the horizontal distance? What's around? 300 seconds. So you essentially got the same thing. You have the same answer, 0.06 meter per second square. Oops. And 6 repeating. That is exactly the same thing as this one, using the graphic approach. And now let's go back to this graph. How about the distance? We can use graph to figure out the distance, because if slope, derivative velocity is acceleration, then how about we integrate the area? How about we integrate the speed with respect to the time? That will give us the distance. So in that situation, we learned about what is integration. Integration is basically area underneath, right? So what's area underneath this curve? It's this triangle area. Can we figure out the triangle area? Yes. So this triangle area is going to equal to half base. Base is 300. Actually, I'm going to write down this right here. So using the graph, the area of this triangle, the base is 300 seconds. The height is 20 meters per second. So the area of this triangle will be half base seconds times height, 20 meters per second. That will second cancel out. Then we will get 3,000 meters, which is the same answer as over here using average speed. So here you basically look at this a problem, figure out the speed, reading the speed from this graph, and you can calculate acceleration using the formula or using the slope. You can figure out the distance using the average speed times time, or you can figure out by using calculus the area underneath the curve. Okay. So we can quickly look at stage 2 then. We can do the same thing as what we did for stage 1. The first thing we want to figure out is acceleration at stage 2. All right. So for stage 2, I'm actually going to just use the graphic approach to quickly solve this. Well, acceleration is going to be the slope. What's the slope of this constant line? That's right. The slope here is 0. So in other words, my acceleration will be equal to 0. And also, alternatively, you can quickly use in the formula delta V over delta T, and final speed minus initial speed, then divided by time. And what's the final speed for this stage 2? It's this point, right? That's 20 meter per second. And what's the initial speed? It's this point, which is constant, 20 meter per second. Then how long does this take? It takes 3,600 seconds. That gives us 0. You got the same answer using different approach. All right, now let's look at the distance. How far has this car traveled during the smooth sailing? And distance is going to be, using the formula, is going to be average speed times time. Well, since this is a constant speed, the average will be exactly that constant speed is going, which gives us is 20 meter per second. And this whole process is 3,600 seconds for 1 hour. Then we can calculate that's going to be 72,000 meter. Okay, we can use graphic approach to quickly verify. Right? So we learned the distance using graphic approach is basically the area underneath this curve. And what's this curve? The area underneath the curve is basically this rectangle. And this rectangle area will be length times width, and the length here is 3,600 seconds, and the height here is 20 meter per second. So the area gave us 3,600 times 20. We got the same answer as well. Right? Okay. So the last stage, stage 3, they want you to find acceleration. Well, be aware this is deceleration, right? If we're going to using our formula, the change in speed, in velocity over time, and we're going to use final speed minus initial speed, either Vf or Vi or V2 minus V1, divided by time. And what's our final speed for this one? It's 0. And our initial speed is this point, right? So that's going to be minus 20. Then divide by time, and this deceleration process takes 180 seconds. So divide by 180 seconds. Then we got our answer. It will be 20 divided by 180, so it's about 1/9 meter per second square for acceleration. But what you realize, it's negative value. And it's expected, right? It's deceleration process. So the final speed is going to be less than the initial speed. We will get negative value. The final thing to calculate is how far the car travels during this deceleration process. And if we were just using graphic approach, we know the distance it travels is basically area underneath the curve. So it's going to be this triangle. And for that triangle, our distance here is the time is 180 seconds, and the height here is 20 meter per second. So knowing that, using half base times 8, then we will get our answer for 1800, and that's in meter. Okay. So the final thing we need to ask is, for this entire process, this car accelerating and smooth sailing and decelerating, how much distance it travels in total, right? So how do we do that? So the total distance. Since you already figure out each 3 segments, you just add them, D1 plus D2 plus D3. And also you can come back to using the area underneath this entire curve. What shape would that be? That would be a trapezoid, okay? So let's use the first approach first to add all the 3. So D1, what's our D1? Going back here, that's 3,000. So 3,000 plus 72,000. Then plus our final distance, that's 18,000. All right, let's add them together. See what do we have. Is that right? Okay. So yeah, so that's going to be our final total distance this car has traveled. Okay, 76,800 meter. Then remember, we mentioned about the distance it traveled is basically the area underneath this entire curve. This entire curve is a trapezoid shape. This entire curve. So now how about if we know the formula for trapezoid area, then we can just figure out this distance in one step. Okay, so let's get the trapezoid dimension here. And this is where the smooth sailing is, right? And that's takes 3,600 seconds. And this entire base, which is acceleration and smooth sailing plus deceleration, so this we said is 300, and this part we said it's 180, and this middle part is 3,600. So add them together, the base will be, let's take a look, 3,600 plus 480, that gave us 4,080 seconds. And what is the height right here, right? That's going to be our 20 meter per second. So what's the trapezoid area? Trapezoid area, if this is A, this is B, this is our H. The area of trapezoid is half of the 2 base add together times H. So seems like we all know all those 3 dimensions. We can go ahead and solve this trapezoid area. Half the top base, 3,600, bottom base, 408, 4,080, and then the height is 20. All right, then let's put it into our calculator. 3,600 plus 4,080 divided by 2 times 20. That gave us exactly 76,800 meter. Voila. Same answer as that one. But think about how long it take us to get this answer. This answer we have to figure out each individual distance, then add them together. But for this graphical approach, figure out this entire process, how long, what's the distance to travel. We're just using this trapezoid area and we got the answer in one step. That's pretty amazing. So in that situation, I want to be aware that using the calculus, the area underneath the curve for speed, time that gave us the distance, and the slope of that gave us acceleration. All right, so that's all for quick recap on the velocity, acceleration, and distance. All right, I'll see you next time. Bye now.